Large language models are getting better every single day, but they have one big limitation. They only know what they were trained on. And if they don't have the details, they start hallucinating. That's why large language models often need help of tools. For example, they can't really do maths by themselves. So they call a calculator tool. Even they can't tell you today's weather unless they connect with a weather API. But what if you want a model to actually know your data, like your notes, your documents, or even your company database? Imagine asking it a question and it responds immediately as it remembers everything for you. So, our challenge is to build a system where we can store our data and retrieve it quickly in a way that large language models can actually understand. So, that's where something called Retrieval-Augmented Generation or RAG comes into the picture. So, in simple terms, here is how it works. First, when you ask a question, the system goes and retrieves the most relevant information from your knowledge base, and then it passes that data to language model. Finally, the model uses both its training knowledge and your data to generate the perfect answer. Okay, so now as we know what RAG is, it's time to understand how it actually works. So the whole process can be divided into three steps: retrieval, augmentation, and generation. But let's also include and talk about storage, as retrieval comes after storage. Well, storage and retrieval is a role of a different model known as embedding model, and the augmentation and generation is a role of large language model or a model through which you communicate. So let's understand the role of embedding models. So the role of embedding model is to generate a mathematical representation or embedding of your data before saving it to vector database. Whenever you ask a query, model convert that query into embedding to get the related information from the vector database. So now as you know what is the role of embedding models, let's go ahead and understand about vector database. So vector database is a database that stores data as a vector. But what is vector? So a vector is a mathematical representation of a data. That data could be a text, an image, or even a music. Think of a vector, a list of floating point values. Each number represents one component, and each component captures some meaning of the data. And when you put them all together, they capture how model understands that piece of data. Let's take an example. If I say a black cat, the model creates a vector for it. Inside that vector, there are different components like it's an animal, it's a pet, it has a color, and it's associated with a domestic life and maybe even cultural meanings like superstitions and all. Now, if I say a wild cat in jungle, the vector looks completely different. Why? Because the whole context changes. Now, the components might include wildlife, forest, predator, and so on. So, how many numbers or components a vector can have? That totally depends on how precise you want the meaning to be. The more dimensions, the richer the detail. Commonly, you will see vectors with 768, 1024, or even more dimensions. That's the standard representation used in many modern models. Now, here is one common confusion. What's the difference between a vector and embedding? Honestly, they are two sides of the same coin. A vector is the raw mathematical data, just numbers, where an embedding is the same vector but with given context, a meaningful representation of your text, image, or audio. So when people say create embeddings, what they really mean is take your data, turn it into a vector, and give it meaning the model can understand. So until this data is inside the DB, it's called as a vector, and once these numbers are provided to embedding models, it will be called as embeddings, because embedding models will understand what these numbers are about. So when you ask a question, say what was the revenue last quarter, the system doesn't waste time scanning every single document. Instead, it uses those embeddings to quickly jump straight to the most relevant piece of your text. All right, so now as we know how RAG system works, it's time for the implementation. So for our implementation, instead of going for any static file, we will go ahead and we'll build our RAG system with a continuous data source. That means we don't have to manually upload or copy paste files every time. Instead, our system will stay connected to our Notion workspace and we will be able to directly talk to our Notion pages using natural languages. Alright, here is my Notion page, which we are going to use as our data source. So we can access this page with help of Notion APIs. So whenever there is a change on this page, we don't have to manually upload it. For API documentation, you can go to Notion Developers Guide. On this page, you can find all the Notion API documentation. Here you can see how you can read a particular block, how you can read blocks of a block. And if you'll follow, all of these APIs requires you to set up a token. And to set up your token, you'll have to go to this link, which is inside your profile. So let's go ahead and follow that URL. So it is notion.so/profile and integrations. So once you'll navigate to this link, you will have option to create a new integration, a test integration, and then you'll have to assign your workspace with. There are two types of integration which you can associate with it. One is internal and then one is public. And for this, we will be going with internal. Let's go ahead and save it. Once you will save it, you can just see and configure your integration. And this is your internal integration secrets. So this is what you will need to access your pages through API. So you can just go ahead, show, copy it, and you'll be all set to use these APIs. So now as we are done setting up our secret, let's say we have to access this particular page using API. So let me navigate you to Postman. If you can follow my Postman, you can see there is this value in the URL. And this is a unique value assigned to a page by Notion. If you'll follow this URL, you see there is this particular page ID. It is called as the page ID. And for your Notion pages, it will be different. So what you can do, you can just copy it and in this particular API, you can just paste it. So you only need two values. One is this page ID, which you can get from here. And the second is secret key. The secret key which we just created needs to be passed as a bearer token here for the authorization header, and you will be able to access your whole page into API. So now we have our continuous data source. It's time to go ahead and set up the DB. So there are multiple vector databases available and you can just go ahead and check that out. But for this use case, we will be using AstraDB. So let's go ahead and set the AstraDB for us. So for AstraDB, you have to search AstraDB in Google search and you have to follow the first link. I already have set up the DB, but I will just also walk you through how you can set it up for yourself. So just go ahead, click on sign in. Once you land on dashboard, you will get an option to create databases. So let's say we have to create a new database. So you can just go ahead, click on create database. For our use case, we need a vector DB and give a DB name, test DB, and provider, you can choose any based on your choice. It doesn't matter. You can just keep the default one as it is, and then you can just choose the region. After the DB is created, it will show its status as active. So if you can follow my screen, you can see there are no data containers. So we need data containers to store the data. There are multiple ways you can create collection. You can create collection directly here, going to Data Explorer into this tab. We'll just click on Data Explorer. Here you'll have to create a collection. Go ahead and click on create collection, select the empty collection. So collection is where we will be saving our embeddings. Give it a name, maybe test collection. So if you remember earlier, we were discussing embeddings as some numbers, and to generate those numbers, we need embedding models. And AstraDB comes pre-built with NVIDIA embedding generation models. So you don't need to go and set up an embedding model unless you want it. Whenever you feed a data into a collection, it will automatically go and will convert those data into embeddings and will save it for yourself. So these are the parameters of embeddings like dimension and similarity metric. So if you remember, we have already discussed dimensions, and dimensions is the number of components in a single vector. And similarity metric is a method to calculate the similarity between two vectors. Okay, so let's go ahead and create our collection. Once you'll hit on create collection, it will take some time to create your collection. And in case if you want, you can just go ahead and load data. But for our use case, we will be loading data from API. And here you can find how you can load data directly into this collection using data API, but you don't need to worry about this because we will be using an automation tool where everything is already sorted. So for automation, we will be using an automation tool, Langflow. If you don't have, go ahead and install it. So once you'll open your Langflow, this is how it will look. So just go ahead and create a project and give it a name, RAG automation. So after you create a project, you will get the option to create a flow. Flow is nothing but automation. So let's go ahead and hit on new flow button, and you'll get option to completely start from scratch, or you can just go ahead and choose these standard templates provided by Langflow. As we're going to implement RAG solution, the best suitable template for us will be vector store RAG. Let's go ahead and select this. Once you land on this flow, you will see there are two different kind of flow. One is a load data flow and another is the retriever flow. So in the load data flow, if you can follow, we got multiple component, files, split text, AstraDB, OpenAI embeddings. So the file is our data source. And as we already discussed, we will be using a Notion API for our continuous data source. So we will go ahead and delete this. Okay, so now we don't need this OpenAI embeddings as well because we already have an NVIDIA embedding model which is pre-built with AstraDB. So let's go ahead and remove this as well. So now we have only two components for our data load flow. One is split text and another is AstraDB. So before we send our data to embedding model, it is important that we split the text into smaller chunks. And a split text help us split the text into multiple chunks. And these are the parameters how you can divide a particular text into chunks. The chunk overlap is a number of characters to overlap between chunks, and a chunk size is the maximum length of each chunk. So basically chunk size is how many characters you can have in a particular chunk, and chunk overlap the number of characters to overlap between the chunks. So embedding model don't lose context between one chunk to another chunk. And this is a separator. So separator can be anything based on your strategy, like it could be a new line or even it could be a paragraph. So now we need a component that can pull the data using Notion API and send it to split text, which will eventually go to AstraDB. So for this, we will create a custom component. I already have a code of a custom component. If you want the custom component code, you can find the link into description. So you can just go ahead and copy the whole component code. So let's create a custom component by clicking this link. What we'll have to do, we'll just have to replace this particular code. So to copy the component code, you'll have to go to my GitHub repository. Here inside the Langflow automations repo, you can find the components. And here you can find Notion API request component. So we can just open it and copy from here. After copying, all you'll have to do is replace this code base and click and save it. Now, if you remember, we created a Notion API key. We also need a block or a page ID. Before that, we will also connect this to split text input. So after you have your Notion API key and page ID, you will be able to run the Notion API component. To complete this flow, we need AstraDB application token. So let's go ahead and create application token. AstraDB. This is the database which we created. And you can find link to create application token right here in the dashboard of databases. Go ahead and click it. The token description is not mandatory. You can just click on generate, copy it and paste it here. All right. So as we are all set, let's go ahead and run this flow. So we see our flow built successfully, and these are all the chunks which we send to AstraDB. So now as we are done with our load data flow, let's move ahead to retrieval part. So retrieval flow is quite straightforward. This is the same AstraDB which we have down in the load data flow. So whatever you chat, it goes straight as a search query which get converted as an embedding using NVIDIA embedding model and then gets searched through, and the output is passed to parser. And based on this prompt, our large language model act on this particular data. So now as we have everything in place, let's go ahead and click on playground to see if large language model have the detail about our document or not. So we'll ask it, what is this document about? And we'll wait for its answer to see if it knows about our document or not. Let's see if it have the detail about our finance related prompts or not. Can you help me with my top finance prompts? So now you can see it goes ahead and finds all our financial prompts. So that was all about how you can create and RAG pipeline and RAG automation. If you want, you can access this whole flow as MCP server. All you'll have to do, you'll have to click on this. And if you have Claude installed on your local machine, you will be able to chat with this pipeline. Thank you for watching. And I hope this video was helpful and you learned something new today. See you in the next one.